going to talk through my answer key. So this is what I'm going to scan in just a couple minutes, but I wanted to talk through it so that if you need a refresher, here you go. So first of all, it says define and graph the greatest integer function. Well, the greatest integer function, that's f of x, is equal to, it looks something like this. So it's kind of those weird brackets where it just has the bottom. And if you're using Desmos, Desmos will call that a floor function. And so what this means is this is asking for the greatest integer less than or equal to x. So let's think about this for just a second. So then the greatest integer less than or equal to x. So say if I have 0. Well, the greatest integer that's less than or equal to 0 would be itself, would be 0. And then if I said, okay, well, 1/2, the greatest integer that's less than or equal to 1/2 is going to still be 0. It hasn't gotten big enough. Let me see if I can say that again a different way. So sorry. I want the biggest integer less than 1/2. So that would be the biggest integer less than 1/2 is 0. If I get to 1, let's say 1/4. Well, it's still 0. If I get really, really big, let's say I have 99 over 100, and I'm getting closer and closer to 0, closer and closer to 1, I'm still 0 right here. I haven't yet made it to 1, but as soon as I get to 1, the greatest integer that's less than or equal to 1 would be 1. The tricky one on this is if I have something like negative 4.2. Okay, if I have negative 4.2, what we want to think about is, okay, where is that on a number line? Well, here's 0, here's negative 4.2, and the integers near it, well, on one side is negative 4, and the other side is negative 5. So I want the greatest integer less than or equal to that, so I can't go to this one right here. I can't just get rid of that decimal and say, oh, it's negative 4. What I have to do is I have to find the biggest integer that's smaller than this number right here, and that would be negative 5. And so when we graph these, you'll notice we started at 0, 0, and then we were cruising along. As my x value changed, my y was the same until I got to 1. Well, then at 1, I jump right up here, and I'm equal to 1. And then I cruise along. If I tried like 1.5 and 1 9/10 and 1.99999, then this, like I'm cruising along here, I stay at 1 until I get to this point. Then I jump up here. Okay, and so this is what a step function looks like. Likewise, we can move, and this would keep going forever. Likewise, we would move down in the negative direction, where I'd have my open circle here, my closed circle there. Okay, and now I can do all the transformations to this particular function than I can to any other one. So if I can make the steps longer, I can space out the steps, and we'll look through some of those very soon.